Hey guys, in this video we're going to look at section 6.4, the central limit theorem. So what does the central limit theorem say? It says for all samples, every sample of the same size n, where n is more than 30, the sampling distribution of x bar, and remember x bar, that is the mean, right? So the sampling distribution of sample means, it can be approximated by a normal distribution with mean mu. So the mean for the distribution of the sample means is the same as the mean of the individuals, and the standard deviation of the sample means is actually the standard deviation of the individuals divided by the square root of the size of the sample. Right? And so, it is telling us that given one, the original population has a mean mu and standard deviation of sigma, right? So that's our given information. And we also need to have a simple random sample of the same size n are taken from the population. So if either of those two things is not given, then we can have problems. So if the sample is not a random sample, then this can have issues. And so practical rules for real applications involving sample means. We have a couple different cases that we'll look at. So our first case that we take a look at is the original population is normally distributed. When it is normally distributed, then it doesn't matter what sample size we choose for any sample size. The distribution of the means is a normal distribution with parameters where the mean of the means is equal to mu, the mean of the individuals, and the standard deviation of the means is the standard deviation of the individuals divided by the square root of the sample size, right? So how are those means distributed when you consider every single mean of size n? And so that is the standard deviation there. If the original population is not normally distributed, so in that case when we have something that is not normally distributed, then we need to have the sample size n be larger than 30. So if our sample size is not larger than 30, then we're going to run into issues, right? And so we need to have our value n larger than 30. If that is satisfied, then the mean of all the values of the sample means is equal to the mean of the individuals, and the standard deviation of all the values of the sample means is just like above, the standard deviation of the individuals divided by the square root of the sample size. If n is less than 30 and our original population is not normally distributed, then we actually can't use the normal distribution. So when n is less than or equal to 30, the distribution of x bar cannot be approximated well by a normal distribution, and the methods of this section don't apply. So on the next page, we will take a look at some more practical implications, and we'll look at an example. All right.